All right, this is the application of our semi-elliptical, so our ellipses. This is a semi-elliptical arch bridge used to make my son's Thomas the Train sets. The arch of the bridge is 2 inches high and spans 6 inches. Find the equation of the arch. Assume the bridge is resting on the x-axis as shown. So we've changed this from the parabola one because now we want it to look like an ellipse. And so it's a semi-elliptical because it's only half of an ellipse. We are not using the bottom one, but I'm going to draw it anyways. And so if you remember, the equation of ellipse is x squared over a squared plus y squared over b squared equals 1. And this would be a, and this would be b. The a is for the x, and the b is for the y. So it's a units left, a units right, b units up, b units down. So it says the arch of the bridge is 2 inches high. So that already tells us that our b is what? It's 2. So we can go x squared over 2 squared equals 1. And then that a is that half of that span. And so it's a span of 6 inches. So if this is 6 inches, then a would equal 3. So this is x squared over 3 squared. So that's x squared over 9 plus x squared over, that's not an x, y squared over 4 equals 1. And so that this gives us is it gives us the location of every single point here. As we move along, we know exactly every single x and y. So if I were to plug in some x value, like here, it would tell me my y value. So there's some x comma y there. Some x comma y on every single point of the graph. So the question is, how much clearance is there for a train that is 1 inch wide? So if I graph my ellipse, right, I put my x and y axis there, then I know my train is 1 inch wide. So you think about that train, it has a width of 1 inch. And when you're going to push this train, you're going to push it down the center. So my train would be here. And we're trying to see, will it clear? All right. So how much clearance is there at that 1 inch? So if it's 1 inch wide, that means it would be half an inch on each side. So that means my x value is a half. It's half of that 1. So now I plug in a half into my equation for the x, and it'll tell me my y. This is 1/4 over 9 plus y squared over 4 equals 1. So what we do with this is that 4 times 9 just gets multiplied. It's 1 over 36. So it's just a fraction divided by a fraction. And then we multiply everything by 36 to get rid of our fractions. So that's 1 plus 9y squared equals 36. Subtract 1. Divide by 9. Square root. And whatever we get for that is our answer. So it is 1.97 is our clearance at that point. So 1.97 inches. So the whole idea is, even though that we have a height of 2 inches for this bridge, it's not going to be 2 inches when our train goes through. It has to be less than 1.97. So really 1.9 and you'd be good. You need a little bit of clearance there. And then these things are not perfect anyway, so I'd even say 1.8. But 1.97 is our height. So that point on our graph would be 1/2, 1.97. So that is the height of our train here, 1.97 max. At 2 inches, it would hit, it wouldn't go through. All right, thank you.